Now, when we're dealing with volumes of revolution, we may not always want to revolve simply around the x or y axis. We may have other um, lines that we want to revolve these functions about. So let's take a look at another example here. Let's find the volume of the solid formed by revolving the region bounded by f of x equals 2 minus x squared and g of x equals 1. Well, obviously, the first thing we need to do to get a handle on this is draw a picture. So if I draw a picture of this, see 2 minus x squared is going to have a y-intercept at 2, and it's a negative quadratic, so it's come down like this. And g of x equals 1, that's a horizontal line at 1. So the region bounded is actually going to be right here. And I want to revolve this about the line y equals 1. So in other words, this is going to rotate about this line rather than an axis. When I do, this is what I'm going to get. And the volume I'm looking for, this is now a solid. It's not between two curves. If you look this way, it's going to look like a football. So the object of the game is going to be to figure out what the volume of that football looking thing actually is. So the first thing I need to do is figure out where these guys intersect. I need to know that coordinate and that coordinate. I need to know what it is down here on the x-axis. So let's just set them equal to each other. So 2 minus x squared equals 1. That implies that 1 is equal to x squared. Then obviously x is going to equal plus and minus 1. So this is a negative 1, and this is a positive 1. Now I need to find the radius. I'm going to be moving along the x-axis here when I integrate. So my radius is going to be right here. It's going to be from this line y equals 1 up to my function. Well, that means, see, this top function here is what we said was f of x. And this is what we call g of x. So my radius, r of x, must be equal to f of x minus g of x. Well, that's going to be, see, 2 minus x squared minus 1. So that is just simply 1 minus x squared. So this is the radius. That tells me this distance here. So now I just simply need to integrate. So my volume is going to be equal to pi times the integral from negative 1 to 1 of the radius squared. So that's going to be 1 minus x squared squared dx, which is going to be pi times the integral from negative 1 to 1 of 1 minus 2x squared plus x to the fourth dx. I simply expanded this. Now I can find the antiderivative. So that's going to be pi times x minus 2x cubed over 3 plus x to the fifth over 5 evaluated from negative 1 to 1. Now, the first thing I'm going to note here is I can simplify this by using symmetry. Whenever I can use symmetry, I typically do it. See, this side on the left is equal to this side on the right. So rather than going from negative 1 to 1, I'm going to do this from 0 to 1 and multiply it by 2. I could have done that up here. I could have put in a 2 right here and then gone from 0 to 1. So I'm going to essentially do that now by making this a 2 and getting rid of that and going from 0 to 1. Because see, all these have x's, so evaluating at 0 is going to be nice because the second piece just simply goes away. So this is going to be 2 pi times, see, 1 minus 2/3 plus 1/5. So that's going to be, let's see, 2 pi times 15 is going to be my lowest common denominator. So this could be 15 minus 10 plus 3 over 15, which is what? 8 over 15? So this is going to be 2 times 8 over 15, which is 16 pi over 15. So the volume of my football looking thing, it's not really a football, but you know, it has that shape to it, is 16 pi over 15 cubic something, whatever the units happen to be.